Morning, dear student. Nowadays, I am continue to discuss half range series of the Fourier series. Half range series of Fourier series. If the interval is 0 to pi, now first of all you can note down the topic. Half range series of period 0 to pi. 0 to pi. What and about the half range series? You can note down if the given function is defined as the interval 0 to pi, then to get the series of cosine series is only even function series of an interval minus pi to pi. If the given function is defined as the interval 0 to pi, then to get the series of cosine series is only the function of even function series of an interval minus pi to pi. Then you can write an is equal to 0 to pi integration an is equal to 0 upon 2 upon an is equal to 2 upon pi integration 0 to pi fx into cos nx dx, where is the interval minus pi to pi. Now next is to expand in half range series of an sine series is an interval minus pi to pi is, you can write the bm and bn is equal to 0. This is the half range series of the cosine series. Now this is the sine series, you can write an is equal to 0 and bn is equal to 2 upon pi integration 0 to pi fx into sine nx dx. This series is called the odd function of the series, is an odd function series. This is called the half range sine series. This series is called the half range sine series. Now you can write the fx is equal to a naught by 2 plus summation n equal to 0 to infinite fx into cos nx. Now this is known as the half range cosine series, and this series is known as, you can write fx is equal to summation n equal to 0 to infinite, you can write bn or you can simply write fx sine nx, or you can write summation n equal to 0 to infinite bn sine nx. Now you can write a naught by 2 plus summation n equal to 0 to infinite an cos nx. An cos nx. This is known as the half range sine series. Sine series. First of all, you can note down the half range series of the period 0 to 2 pi. Now I am continue to relate some numerical related to half range sine series and cos series. Now you can note down this numerical problem. To some numerical problems related to the half range sine series or a cos series. This is a numerical for half range cos sine series. You can read. Find the cosine series of the fx is equal to pi minus x in the interval 0 is less than x is less than pi. Now, first of all, you can note down the solution of this problem. You can note we have fx is equal to pi minus x at 0 is less than x is less than pi, then by half range cosine series you can write fx is equal to a naught by 2 plus summation n equal to 0 to infinite an cos nx dx. Sorry, this is n equal to 1 to infinite. Now, first of all, find the value of a naught. A naught is equal to 2 upon pi integration 0 to pi fx into dx. Now you can write 2 upon pi integration 0 to pi. Put the value of fx. This is equal to pi minus x into dx. You can write 2 upon pi bracket pi x minus x square by 2, the integration of this function. Now limit 0 to pi. Now a naught is equal to 2 upon pi. Put the limit of 0 to pi. First off, put the limit of upper limit. This is equal to pi square minus pi square by 2 minus 0. Now you can write 2 upon pi into pi square by 2. You can write a naught is equal to pi. This is the value of a naught. Now again find the value of an. An is equal to, you can write 2 upon pi integration 0 to pi fx into cos nx dx. Now put the value of this. You can write 2 upon pi integration 0 to pi minus x into cos nx dx. Now integrate of this function. You can write 2 upon pi bracket. First of all, you can integrate of this function. You can write pi minus x into sine nx total upon n minus. Now differentiate of this function is called minus 1. In integration of this function is called minus minus plus cos nx upon n square. Now limit 0 to pi. Now you can write 2 upon pi bracket pi minus x sine nx upon n minus cos nx upon n square is limit 0 to pi. When the limit 0 to pi of this function is even function. Now the value of this function will be 0. Now putting the limit of this function, you can write an is equal to 2 upon pi bracket minus 2 upon pi cos pi n upon n square minus cos 0 n upon n square. Now you can write minus 2 upon pi bracket. This is minus 1 to the power n upon n square minus 1 upon n square. Now you can write 2 upon n square pi bracket 1 minus minus 1 to the power n. Or you can write the simply an is equal to, if n is equal to odd, if n is equal to even, you can write 0 for n is equal to even. Now 4 upon n square pi, where for n is odd, n is equal to odd. This is the value of an. First of all, you can note down this numerical problem. Now again I am continue to next step. Now you can note down this numerical problem. Now I am continue to this step. You can write by half range cosine series. You can write fx is equal to a naught by 2. This means pi by 2 plus, you can write the value of an. This is equal to this. You can put 4 upon pi bracket. If n is equal to 1, you can write cos x plus cos 3x upon 3 to the power 2 plus cos 5x upon 5 to the power 2 plus, and so on. Now you can write fx is equal to pi by 2 plus 4 upon pi bracket. You can write this is equal to cos x plus cos x total upon, sorry, this is 3x total upon 3 to the power 2 plus cos 5x upon 5 to the power 2 and so on. This is your final answer. This is your final answer. Hence, prove that this is the value of the half range cosine series. First of all, you can note down this numerical problem. This is a very important for your examination. And again, related to the sine series of this numerical, the value of sine series is equal to summation n equal to 1 to infinite bn sine nx. First of all, find the value of bn, because the sine series function is a odd function. Now I am continue to the next topic related to the Fourier series. First of all, you can note down. Now I am continue to the next topic related to the Fourier series. This is very important because if the time period of the pendulum is changed in an arbitrary constant or arbitrary value, if the time period is not equal to 2 pi, or you can say t or a 2c, and this is a changeable variable of the x is proportionally. Now first of all, you can note down the topic: change of period having arbitrary constant. Arbitrary period. Now, first of all, you can note down in electrical engineering problem, in electrical engineering problem, the period of the function is not always 2 pi, but t or 2c. Then the value of independent, the value of independent is independent, this is x, is always, always, always proportional, proportional. Now, in an electrical engineering problem is always create if the time period of the function or interval is not equal to 2 pi, or you can say t or 2c, then the value of the independent x is always proportional or changeable. Now let let the function fx is to change the period t or 2c, you can say the interval, say the interval, say the interval minus c to c, then the value of a naught, an and a naught comma bn will be changed, will be changed. Now the value of an and a naught and bn is, you can write, you can write why the formula of a naught, an and bn are, since 2c is the form of interval x, and since now 1 is the form of interval is equal to x upon 2c. Now therefore 2 pi is the form of interval interval is equal to, you can write x upon 2c into 2 pi. Now you can write this is equal to pi x upon c, so that let this is the value of z is equal to pi x upon c, and x is equal to cz upon pi. Thus the function fx of period 2 pi is transfer to f cz upon pi is equal to capital Fz of period 2c, then the value of a naught, an and bn are, now you can note down this problem. This is very important for the electric engineering problem, numerical solve of the electric engineering problem. The electric energy problem, there is the more problem too if the time period is not equal to 2 pi, or you can say the time period is C minus C to C, or you can say T to 2C. This is the value of the arbitrary constant x is independent, or you can say the proportionally of the x. Now you can note down this numerical problem. Z is equal to x pi upon c, or you can say x is equal to cz upon pi. Now the value of capital Fz is equal to small cz upon pi of the period 2 pi. Now expand the Fourier series. You can write fx is equal to a naught by 2 plus summation n equal to 1 to infinite an cos nz, you can say, plus summation n equal to 1 to infinite bn cos, sorry, this is sin nz, or you can write a naught by 2 plus cos z, sorry, this is the value of a1 cos z plus a2 cos 2z plus and so on, plus b1 sin z plus b2 sin 2z plus and so on. Now find the value of a1, a2, a0 and b1, b2, b3. Now first of all find the value of a0. A0, this is equal to 1 upon, you can write 1 upon pi integration 0 to 2 pi f, sorry, you can write capital F z, this is equal to capital Fz, this is equal to capital Fz. Now Fz dz. Now you can write the value of this 1 upon pi integration 0 to 2 pi, you can write small f cz upon, or you can write f cz upon pi, cz upon pi into dz, you can write this is equal to 1 upon pi integration 0 to 2 pi, this is equal to cz upon pi, this is equal to small fx into d, you can write this is equal to d. Now you can write cz upon pi into multiplication of pi upon c. Now you can write 1 upon c integration 0 to pi 2 pi fx into dx. This is a value of a naught. This is a value of a naught is equal to 1 upon c integration 0 to 2 pi fx dx. This is a value of a naught when the period is a arbitrary period. Now again the value of an, the value of an is equal to, you can write 1 upon pi integration 0 to 2 pi capital Fz into cos nz dz. Now you can write 1 upon pi integration 0 to 2 pi small f cz upon pi, this is capital Fz and this is small fz. Now again into cos n pi, sorry, this is n z upon pi into c into dz. Now you can write 1 upon pi into pi upon c integration 0 to 2 pi, this is equal to fx. Now no, sorry, this is not equal to this, this is nz, this is nz, this is nz into dz. now into cos nz into d cz upon pi. Now you can write 1 by c integration 0 to 2 pi fx into cos, put the value of z, this is equal to n pi x upon c into dx. This is the value of an. This is an is equal to 1 by c integration 0 to 2 pi. You can write this fx into cos n pi z upon c into dz. This is the value of an. This is the value of an for arbitrary period. For arbitrary period, the value of bn is equal to 1 upon pi integration 0 to 2 pi. You can write capital Fz into sine nz dz. You can put the value of this, you can write pi integration 0 to 2 pi small f cz upon pi into sine nz into dz. You can similarly write 1 upon pi into pi upon c integration 0 to 2 pi. This is a value of fx. Now put the value of z, you can write sine n pi x upon c into d z pi upon c. You can write the value of ben is equal to 1 by c integration 0 to 2 pi fx into sine n pi x upon c into dx. This is a value of bn. This is a value of bn. This is a value of a naught, and this is a value of an for the arbitrary period. Minus c to c if the interval is minus c to c. Now first of all note down this, the value of a naught, an and bn for arbitrary value if the time period is not equal to 2 pi, or for electrical engineering problem the time period is always not equal to 2 pi. This is equal to arbitrary value. Now I am discuss some numericals related to this topic. First of all you can note down numerical problem related to arbitrary period. First of all, you can read a periodic function of the period 4 is defined as fx is equal to mod x as minus 2 is less than x is less than 2. Find its Fourier series expansion. Now this is an arbitrary value of the period minus 2 to 2. You can say, you can first of all you can write solution of this problem. We have fx is equal to mod x as minus 2 is less than x is less than 2. Now you can write x as 0 is less than x is less than 2 minus x is minus 2 is less than x is less than 0. This is the value of this function, or you can draw of this function. You can draw this function. You can draw, this is the x, this is y, and this is minus x. This is the origin point O. This is the value of 0 to 2 if fx is equal to minus x. Now this is the value of, this is equal to 2. This is the value of fx is equal to minus x. Now find the value of a naught, an and bn. Now the value of c is equal to 2. Now first of all find the value of an is equal to 1 upon c integration 0 to 2 pi fx dx. Now put this value, you can write 1 upon 2 integration 0 to 2 0 to 2 0 to 2 dx minus 1 upon 2. Put the value of fx is minus x. You can write minus 2 to 0 x into dx. Now you can integrate of this function. 1 upon 2 is common. Now integrate of this function. You can write x square. Now limit is 0 to 2 minus x square by 2. This is x square by 2. Integration of this function. Now limit minus 2 to 0. Now put the limit of this function. You can write 1 by 4. This is 4 minus 0. Now minus, put off this limit. This is equal to 0 minus 4. You can write this is 1 upon 4 into a. Now you can say the value of a naught is equal to 2. The value of a naught is equal to 2. Now again find the value of an. Find the value of an. You can write an is equal to 1 upon c integration 0 to 2 pi fx into cos n pi x upon c into dx. Now put all the value of this function. You can write 1 upon 2 integration 0 to 2 x cos n pi x upon 2 into dx minus 1 by 2 integration minus 2 to 0. This is a limit. Minus 2 to 0 x cos n pi x upon 2 into dx. Now integrate of this function. You can write 1 by 2 integration of this function. You can write x cos n pi, sorry, now integrate of this function. You can write x x into sine n pi x upon 2 total upon n pi upon 2 minus, now integration of differentiate of this function is 1 into integration of sine, this is minus minus plus, cos n pi x upon 2 total upon n pi upon 2 to the power 2. Now limit 0 to 2. Again the integration of this function. You can write x sine n pi x upon 2 total upon n pi upon 2 minus minus plus 1 into cos n pi x upon 2 total upon n pi upon 2 to the power 2, limit minus 2 to 0. Now put the limit of this function. You can write 1 by 2. The value of this function is equal to 0. Now the value of this function is 4 upon n square pi square cos n pi minus the value of this is equal to cos 0 pi, now minus 1 upon 2. Now put the value of this limit. You can say this is equal to 0. Now you can write 4 upon n square pi square cos 0 pi minus cos n pi. Now you can note down this step of this numerical. Now I am continue to again this. Now you can solve 8 upon n square pi square. You can write this is equal to minus 1 to the power n minus 1 to the power n minus 1 minus, put this 1 minus 1 to the power n. Now you can note down. First of all you can note down. Now I am continue to the next step of this numerical. Now you can write 8 upon n square pi square. Now you open this function. You can write minus 1 to the power n minus 1 or you can say minus 8 upon n square pi square 1 minus 1 to the power n, or you can say the an is equal to, for n is equal to even, the value is 0. For n is even, and again for n is equal to odd, the value is now this is the 4 into 1 by 2. This is 1 by 2. Now you can write the value is 4. Now this is the value of minus 8 upon n square pi square. This is the value is 4. This is the value is 4 for n is odd. N is odd. Now again find the value of bn. Since the given function is an even function, therefore the value of bn is equal to 0. bn is equal to 0. Now by Fourier series, you can write fx is equal to a naught by 2 plus summation n equal to 1 to infinite an cos n pi x upon c, or you can write the value of an is equal to 2 by 2 plus, this is even and this is odd, you can write minus 8 upon n pi square bracket, put the value of a odd, you can write cos x plus cos 3x upon 3 to the power 2 plus cos 5x upon 5 to the power 2 plus 1. Now you can write fx is equal to 1 minus 8 upon pi bracket cos x plus cos 3x upon 3 to the power 2 plus cos 5x upon 5 to the power 2 and so on. This is your answer. This is your answer. Now, if you have any problem related to any numerical of the Fourier series, please comments to my video and watch again to again for solving the numerical problem related to the Fourier series for odd function and even function and having arbitrary period of the Fourier series. Thank you for watching my video, and please like and subscribe and promote to my channel Dual Mathematics. Thank you.